Angles, written and presented by me, John LeGuy. Here's the legal stuff. Around about 6,000 years ago, the Babylonians figured out that there were 360 days in a year. They liked 360 because they liked 12s and they liked 60s, and it fitted. They knew the Earth was a ball, and they figured the Earth and the Sun travelled in circles, so they divided the circle into 360 degrees. About 5,500 years ago, the Greeks applied the 360-degree system to the Earth to get latitude and longitude. For greater accuracy, each degree was divided into 60 minutes, and each minute was divided into 60 seconds. So that if you look at Carlisle campus, it's at 31 degrees, 59 minutes and 14 seconds south, 115 degrees, 54 minutes and 54 seconds east. South because we're in the southern hemisphere, and east because we're east of Greenwich, which is on the 0 longitude called the prime meridian. If I get a circle and I stretch a piece of string across it, the diameter, if I then take that bit of string and I lay it on the circumference of the circle, it'll go around once, and then twice, and then 3 times, but not quite. It'll go around 3 and a bit times. So, if you take the circumference and you divide it by the diameter, which is what I just did, you actually get this number, 3.142, and it just goes on and on and on. And that number is what we call pi, which is the circumference divided by the diameter. If I was to do the same sort of thing but with a radius, then let me just get that up. There's a radius. I drew it in green this time, doesn't show too well on there. So a radius will go round once, twice, 3 times, 4. And by the way, 3 is not halfway round. 5 and 6. So a radius goes round 6 and a bit times. Now, from before, we saw that pi is actually the circumference divided by the diameter. So if I put radius instead of diameter, then pi is the circumference divided by 2 times the radius. Rearranging that, I get circumference is 2 pi times the radius. Or in other words, there are 2 pi lots of radiuses in a circle. We can use this idea to express angles in radians. We have to abbreviate that to rads, where 1 radian is the distance travelled around a circle by a piece of string that's 1 radius long. So that angle there is 1 radian. Now from before, we saw that 2 pi radians was all the way round. It's 1 complete circle. So that's 360 degrees. Halfway round then must be a pi radian, 180 degrees. A right angle must be pi over 2 lots of radians, 90 degrees. And 3/4 of the way round will be 3 pi over 2 radians, 270 degrees. So rather than expressing angles in degrees, we can express angles in radians, where there are 2 pi lots of radians in 360 degrees, or a complete circle. The advantage of radians over degrees is that radians relate to an inherent feature of a circle. They're not just some random number that some ancient Babylonian just dreamed up one day. You need to know where degrees and radians came from, and you need to be able to convert between them.